Hello, class. This is going to be the recorded lecture for section 3.2 in our textbook here in our Trig class. And this is starting the process of introducing the trig functions. And so there are really two approaches to it, and we're going to go over both of them. There's the right triangle approach. And in my mind, I think triangles are easier than circles. So I kind of like this one. And then there is the unit circle approach. That actually is back in chapter 2. So we're going to do the first 3 sections of chapter 3 and then bounce back to chapter 2 and show you how that aspect of it works, trig works with regards to a unit circle. So we actually have 3 or 6 trig functions: sine, cosecant, cosine, secant, tangent, cotangent. Be bluntly honest with you, the 3 that I've used in my life, besides teaching math, is sine, cosine, and tangent. Never used the other 3. But basically the other 3 are what we will call inverses of the main 3. And so I guess they could somehow be useful. I've never used them with regard to that, but the main part of this whole class is focusing on those main 3 functions anyways. So before we define those functions, I want to introduce this idea of a right triangle. So hopefully you kind of have this idea back in your mind in geometry, and maybe you remember the really important theorem in right triangles, which is Pythagorean theorem, which we'll go over again. So this is how we define this right triangle. It has 2 sides, and then it has the hypotenuse. And where the 2 sides intersect is intersecting at a right angle. So what I'd like to do here now is, whoops, sorry about that, I hit the wrong button, is draw myself a right triangle over here. Oh, not too bad. So here's our angle of 90 degrees, which gives us the right triangle. And so what we're going to do is define this angle here from this side to the hypotenuse, and we're going to call that theta. And so in this right triangle approach, we still use the term hypotenuse for the hypotenuse side. But the side that's touching the angle, this one right here, we call it the adjacent side, and we abbreviate it ADJ. And the side that's opposite of this angle, doesn't touch the angle, right? We call that the opposite side. And so typically those are abbreviated as I have on this figure here. And with this, we'll be able to define sine, cosine, and tangent. And then it will allow us to define the other 3 functions as well. So I'm going to go back to the presentation here. And so as I said on my graph, these are how the 3 sides are indicated and abbreviated. And so how do we define the trig functions? Here we go. It's like, oh my, look at all these equations. Well, the 3 that you want to remember are sine, cosine, and tangent. And the other 3 are just inverses, and I'll show you that shortly. So the idea is that the sine function is the length of the opposite side divided by the length of the hypotenuse. And then cosine is actually the adjacent divided by hypotenuse. And tangent is opposite over adjacent. And then you could see the other 3, cosecant, secant, and cotangent. which are just flip-flops of one another. So I do want to point out that this is the first of the formula sheets that I uploaded to Brightspace. This is by far be the most useful tool that you will have throughout the whole semester. So download this and keep this handy. If you can print it out, if you like having a piece of paper, that'd be great. But at least have it handy so you could refer to it. And as you can see right here in the upper left-hand corner, the definitions of everything we just talked about is outlined right here. And so it's nice to be able to refer to this with regards to that. So going back to the whiteboard here, I just kind of want to show you what I mean by the other three trig functions are just inverses of the main one, sine, cosine, and tangent. So sine is related to, say, cosecant. Let me show you how that works. So again, we define sine of theta as opposite over hypotenuse. And cosecant is defined as the hypotenuse divided by opposite. So you could see that if I did this, 1 over cosecant of theta, whoops, looks like I forgot one thing here. There we go, cosecant of theta. When you do this, what you do with this fraction is you flip it. So now we bring the opposite on top and the hypotenuse on the bottom. And you can see that equals sine of theta. So let's see. You can see on our formula sheet, we have these basic identities that we are defining here as well. And so that concept, again, will be very useful, especially when we start doing some calculations in chapter 4 for sure. So let's talk about how to do a calculation. So say like, let me just clear this and start over. So let's start with something that looks like this. It's a really bad right triangle. Let me start over. So it's usually better to start with the hypotenuse. Theta. So say like I say, this side is side 3. This is side 4. And I said, let's find the sine of theta, cosine of theta, and tangent of theta. So let's start with tan of theta. So tan of theta, again, is defined. And again, if I teach this, so I remember these now, but that formula sheet will come in handy. It's opposite over adjacent. And so here's theta. And what is the opposite? That would be 4, right? And what is the adjacent? That would be 3. So the value of tan theta by the definitions of these functions is 4 divided by 3. Not too bad, right? So how do we find sine? Well, sine of theta is opposite over hypotenuse. Well, we know that the opposite is 4, but we don't know what the hypotenuse is yet. So here's where the old Pythagorean theorem comes in. Do you remember a squared plus b squared equals c squared? Well, c squared was the hypotenuse. So this is the hypotenuse over here when we're talking about the c value. Typically, the a value was the adjacent and the b value is the opposite. So when you do this calculation, you get 3 squared plus 4 squared equals c squared, right? And so this would be 9 plus 16 equals c squared. So 25 equals c squared. And when you take the square root of both sides, what do we get? C equals 5. So now we know that the c value equals 5, which is the hypotenuse. So that would be 4 over 5. So what would be cosine of theta? Well, cosine of theta is adjacent over hypotenuse. And that would be 3 over 5. So that really is the first introduction with regards to making these calculations. And our definition says that cosecant of theta is 1 over sine, right? And so instead of it being 4 over 5, that would be 5 over 4. And then secant is 1 over cosine of theta. And so that would be the 5 over 3. And then the last one is cotangent of theta. And that's tan of theta. Sorry, 1 over tan of theta. So instead of 4 over 3, it would be 3 over 4. So that is the introduction to section 3.2. So I'm going to stop this video and then we're going to continue on a different